talk about geometric probability. So in a binomial setting, the number of trials n is fixed and the binomial random variable x counts the number of successes. In other situations, the goal is to repeat a chance behavior until a success occurs. And these situations are called geometric settings. So a geometric setting arises when we perform independent trials of the same chance process and record the number of trials until a particular outcome occurs. Okay, so the difference between binomial is I have something called a success, something called a failure, and I have a fixed number of trials. I'm going to do something either 10 times, 5 times. Geometric setting means I'm going to continue until I get so many options. So there are a set of conditions that we need to check for this. And this is the bits. So B stands for binary. Again, we still need something called a success failure. We still need it to be independent. Trials must be independent. That is, knowing the result of one must not have any effect on the result of any other. T stands for trials. This is the biggest difference between binomial and geometric. Geometric, the goal is to count the number of trials until the first success occurs. And lastly, on each trial, the probability of success must be the same. So make sure to check the conditions for bits. So in a geometric setting, if we define the random variable y to be number of trials needed to get the first success, then y is called a geometric random variable. Probability distribution of y is called a geometric distribution. Again, the key difference, the number of trials of y that it takes to get a success in a geometric setting is a geometric random variable. And the probability distribution of y is a geometric distribution with parameter p, probability of success on any trial, and the possible values of y are 1, 2, etc. So note, like binomial random variables, it is important to be able to distinguish situations in which the geometric distribution does and doesn't apply. So if y has a geometric distribution with probability p of success on each, the possible values of y are 1, 2, 3, etc. And here's a formula that we can use to find the geometric distribution when we're looking for the probability of y equaling a certain value. Again, we can take 1 minus p complement of probability of success, so probability of failure raised to k minus 1 times the probability of success. Luckily, a calculator will do that work for us, again, just like with binomial, except if I don't have a fixed number of trial, if it asks, well, what's the probability until I get so many times occurring, then that's going to be a geometric PDF. So again, still go to menu, statistic, distribute, probability, distributions, geometric. Or if it's CDF, again, menu, statistics, probability, geometric. CDF. Expected value for a geometric random variable is u equals 1 over p. And standard deviation formula is given as such as well. So I believe these are on your AP formula sheet. You can check for those formulas there. So let's look at some examples. So let's say we have the example, only 4% of people have type AB blood. So one says, on average, how many donors must be checked to first find someone with type AB blood? Well, expected value for geometric is going to have the equation 1 over p. Well, what is our p? 4% is 0.04, so 1 divided by 0.04 is 25 donors. So what's the probability that at most 5 will have to be checked before first finding someone with type AB blood? So at most 5 means I don't have a set number of trials, so it is geometric. So you can utilize your calculator. So how we must show these steps for the AP test: geometric CDF, probability is 0.04, Since it says at most 5, that it goes from 0 to 5. So lower bound is 0, upper bound is 5. Again, you can go to menu, statistics, probability, and scroll all the way down to geometric CDF. Calculator should give you a 0.185 or about 18.5%. So 3 says, what's the probability that we won't find a type AB donor before the 10th person? So again, we don't have a set number of trials, okay? So it's going to be geometric. Again, CDF must show these steps for AP credit. Probability is still 0.04. Lower bound is 10. And since it says before the 10th, we want just, your upper bound is basically infinity. So you can just choose a large number. 1,000 normally works. 10,000 if you want. And total will be 0.6925 or about 69.25%. So last one, what's the probability that out of 10 donors, at least one have type AB blood? Well, notice it says out of 10. That's a fixed number. So this is not geometric. This is binomial. And it says at least, so that is going to be CDF. So again, must show this calculator step work if using the calculator. And again, you're just listing anything the calculator asks for. So n equals 10, b equals 0.04. And again, at least 1 means 1 and everything above. And out of 10, the max number is 10. So calculator can do the work for you, and we get 0.3352.
May I come in? Thank you, ma'am.